There are some selfies being taken, but we really need to get started again. We're on a tight schedule. Remember, else I take your lunch break away. Everybody's like, what's lunch break? I need to take a picture with Mats. Okay. So, we'll have 2 talks. They'll be great. Then there will be a lunch break, which means you need to go outside. I've also been told, and it's people, come on, tight schedule, silence. I have no authority on this stage, do I? No authority. I love the, yeah, yes, yes. All right, we have 2 talks scheduled, then there's a lunch break. As long as you cooperate with me, I don't take more of your lunch break away. If you don't, you know the consequences. I have been told there will be coffee and such, whatever such means, but I'm guessing like fruit and stuff, in the next break. So break after lunch, I'm guessing, because we're all going out for lunch. Yes, so that's happening. We need to do some sort of technical stuff here, so I'm just going to announce the next speaker right away and stay on schedule. Breaks are for talking. Conference room attendance is for not talking and for listening. Again, thank you, my kind volunteers in the audience here, for the clapping and the shhing. Works really well. So, our next speaker is originally from Canada and now lives in Japan. He is the author of Mobility and a open source contributor. He's also very active in the Japanese Ruby community. And he will be teaching us all more about metaprogramming, because it's the machinery that drives Ruby. So we'll be learning about writing modular extensible code, tackling the real hard problems. And his goal is that we all walk away from here having some sort of conceptual understanding to all be generalists, because according to Chris, that's what we need more of in this community. So give it up to Chris.
Hello, hello, okay. Hi everybody, my name is Chris Salzberg. The title of the talk is Metaprogramming for Generalists. I apologize, it's the first morning of the first day and we're starting with metaprogramming. Don't worry, it'll be interesting. Okay, so some quick points about me. My handle is Shioyama, if you've seen that name around. I live in Tokyo in Japan. This actually background picture is if you can see that, it's the neighborhood where I live. Don't be fooled. I'm not Japanese, in case that wasn't obvious. I'm Canadian, originally from Montreal. I work at a company called Dejika. We have a booth outside, check us out. In the open source world, I'm the author of a few gems. The most well-known is called Mobility, for translating model data. And I write about things like the module builder pattern at my blog, dejimata.com. Okay, enough about me. This is a 2-part talk. The first part, I'm going to present kind of a new way of thinking about metaprogramming, which is going to be, I think, more relevant, more meaningful for solving generic problems. And in the second part, we're going to solve a generic problem and build a kind of a concrete example of what I'm going to refer to as generic software. Okay? So, generalist metaprogramming. So, it's Ruby's 25th birthday, and I think more than maybe any other area, metaprogramming is really an area where Ruby stands out among programming languages. It's something that Ruby really embraces. It underlies all those things that Matt's just mentioned about Ruby, the kind of human-like syntax, the DSLs, just the nice use of it. They're all kind of, a lot of those things are underlined by metaprogramming. But we have a really hard time defining this thing. Programmers in general have a hard time. It's a noun. We can agree on that one. That's about all we can really agree on. The first basic definition is if programming is writing code, then metaprogramming is writing code that writes code. Second definition, this is from Wikipedia, technique in which computer programs have the ability to treat programs as their data. This is also called reflection. This is a bit better, a bit broader. In other ways, this is called introspection. A way for a program to find things out about itself or other programs is also important. But then at the end of the day, I mean, people can't seem to agree, so we just kind of throw our hands up in the air and say it's like a bag of tricks. This is actually from Metaprogramming Ruby, which is a great book. I recommend it. What are those tricks? They're things like this. Some of you may have seen many of these things. Monkey patching, yield self. Matt has an opinion on that one. Lots of stuff here. But in practice, I think we use a different working definition, which looks more like this, which is that we just kind of label certain methods in Ruby as being kind of metaprogramming methods. And the classic one is eval, of course, but also stuff like define method, method missing, instance eval, and then even send, depending on where you kind of draw your boundaries. And this is kind of, I'm going to call this the what view of metaprogramming. This is metaprogramming. If you're using those things, okay, that's metaprogramming. And a lot of the talks and the blog posts and the writing and the speaking and everything out there starts from this. It says, okay, these are the methods, this is how you use them, describes that kind of stuff. But I don't want to do that today. I don't want to do that today because of this. So if we zoom out on that view, this is kind of the result, or this is how we see metaprogramming as a community, I think. We see it as kind of this niche topic, this like fringe. It's kind of like scary or magical or, I don't know, or maybe just not relevant to us, most of us. But then for another part of the community, which includes myself, and I suspect maybe a lot of people here today, this is not how we see it, right? Metaprogramming is really central to Ruby and what we do with it. And I think the reason for this divide is because, like I said, the stuff that's out there, where we talk about metaprogramming, we don't answer the obvious question, which is, what on earth is metaprogramming for, right? What is it for? So that's what I want to try to tackle today. So to do that, we're going to think of the role that metaprogramming plays in our ecosystem. So start here with a fire. We put Ruby in the fire. Matt's is feeling the heat now. So down here we have the Ruby committers building this language we love. Up here we have the applications, right? This is where most of us are most of the time. We're building stuff that pays the bills for us, and we use Ruby. We look down at it, we know how to use it, but we don't necessarily know its internals or care about them unless stuff goes wrong. But this is not everything, obviously, right? I'm missing a layer here, and that layer is the libraries, which are the gems. I'm going to use libraries and gems interchangeably here. So what do the libraries do for us? Like in any programming language, they fill the gaps that more than one application need that the programming language does not provide. And in Ruby in particular, these libraries blend almost seamlessly into the programming language itself. Active support is a classic example of that. So what does it have to do with metaprogramming, right? So the point here is that metaprogramming overwhelmingly lives in this middle layer. And the classic example is sort of active record, all your attribute methods, your association methods, all stuff. It's all created using metaprogramming. But it's not just Rails, it's not just active record, it's lots of gems. Not all of them, but a lot of them heavily uses. But when you go to the application layer, you don't see this very much. Maybe you see monkey patching a little bit here and there, but you don't see a lot of this stuff there, right? So this brings up another, I think, obvious kind of question, which is, why? Why? Like, why is metaprogramming so prevalent in our libraries but virtually non-existent in our application code? So I think this is actually a really important question, and I don't think anybody's asking it, let alone trying to answer it. And I think part of the reason for that is maybe because it seems kind of obvious, but actually I think the answer is a lot more subtle than that. So I want to try to think about that together today. So to do that, we're going to look at another word. This is a word the root of the second big word in the title of this talk, which is generalization. Generalization is what libraries do, right? They generalize problems that more than one application has into generic components that we can use in all our applications. So here's a definition again from Wikipedia. Formulation of general concepts from specific instances by abstracting common properties. So this part, abstracting common properties from specific instances, I'm going to go into this in detail in the second part of this talk. Okay? We're going to actually take a concrete example of this and see how that works. But for now, I want to focus on this part, the general concepts. What is the role that metaprogramming plays in general concepts? Because general concepts is what our libraries, what our gems implement for us. So to do that, we need a general concept. So I'm going to pick this one. I'm going to wager that this is a pretty relevant concept for everybody here, the concept of attribute. Now we want to understand what role metaprogramming plays in the concept of attribute. So how are we going to do that? We're going to take a cue from genetics. I don't know if there's any biologists in the room. If there are, I apologize. But in genetics, if you want to understand what role a gene plays in, say, a mouse's DNA, what do you do? Well, one of the things you do is use a knockout experiment. You knock out the gene, and then you look at the mouse with the gene and the mouse without the gene, and you look at the difference, right? So we're going to do this. We're going to take the concept of attribute, and we're going to knock out metaprogramming, and we're going to see what we get. This should be fun. So control is science speak for the case without the knockout, so with the gene. So this is our library, okay? This is our control library. This is with metaprogramming. This is going to be a really, really simple case because I can't do any more in a 30-minute talk. So we have a library. The gem has a single class called model. It's got an initializer. It sets a blank hash of attributes. And then it's got a single class method called define attribute. And you pass define attribute an attribute name, and then it creates a setter and a getter. And the getter takes the name and then fetches the value for that key on the hash. And the setter sets the value for that key on the hash. It's very simple, right? So this is our library. This is our gem, okay? Now we're going to switch to the application point of view. This is the application implementing this very, very simple library. We have a class talk. Talk inherits from model. We call define attribute twice for two attributes. We define title and abstract. And then we create a talk. We set the title, we get back the title. We set the abstract, we get the abstract. Really, really simple stuff, I know. Okay, I just want to highlight one thing. The abstraction here is transparent, it's invisible. What's the abstraction? The abstraction is attribute, right? You see the word attribute when you define the attributes, but once you define them, you don't see them when you're using them. You just call title equals or title, right? Okay, that's it for that one. Now we're going to go to the knockout. What happens in the knockout? So remember, the knockout case is without metaprogramming. We don't have metaprogramming. So we have, again, a class model, initializer, same, just set a blank hash of attributes. But now we can't define the methods dynamically because we don't have metaprogramming to do that. So instead, we do the only thing we really can do. We define two instance methods, get attribute and set attribute. And they do the same thing as before. You pass the name of the attribute in now, and then in the body, it's the same. You just fetch the key on the hash. Same thing for the setter. You just set the value for the key on the hash. Really simple stuff. That's our library. Now again, now we switch to the application that implements this thing. So again, we inherit from model with talk. We don't have to define the attributes because we're just going to allow you to set or get anything you want. It doesn't really matter. We create a talk. We call set attribute. We pass the name of the attribute title and then a value, and then we can get it back. And same thing for the abstract. Okay, it's pretty simple stuff. I want to highlight here, this is a really simple example, but there's some really subtle important things here. The abstraction is now visible, right? What's our abstraction? Our abstraction is attribute. Okay, when you want to set the attribute or get the attribute, you have to actually call set attribute. Remember that in Ruby, when you call a method, it's the same thing as sending a message to the object, right? And so in the first case, with metaprogramming, the control, the message we sent was title, or it was abstract, or title equal, or whatever. But now our message is set attribute, or get attribute, right? The word attribute, the abstraction is right there. And what happens to the attribute names themselves? Well, now they're kind of second-class citizens, right? We're passing them as arguments on these methods, set attribute and get attribute. Okay, we're going to tabulate the results of our little experiment here. We have two rows, application and library, for application view, library view, and then we have two columns, control and knockout. Again, the control is with metaprogramming, and the knockout is without metaprogramming. So in our first row for the application, what happened, right? So in our control case with metaprogramming, in the application, the abstraction was invisible. Remember, we just called title, or title equal, or whatever. We don't have to think about the abstraction, which is attribute. We send the attribute name as a message to the object. So we can say in this case that the library speaks in the language of the domain. What's the domain? The domain in this case was talk, and title, and abstract, but it could be whatever the application domain is. What happens in the knockout without metaprogramming? The abstraction is now visible, right? It's in your face. You have to send the attribute names now as arguments to the method. So we can say that in the knockout case, the library speaks in the language of the abstraction, right? You can't actually get around this. The library has to do this because you don't have metaprogramming. What happens in the library now? So our library here was like really, really simple. So I'm going to show a slightly more interesting example in the second part. But for now, I want to focus on this term unknown. This term unknown is going to be really important for understanding what metaprogramming is actually doing for us. So in the case of the control with metaprogramming, remember, in the library, our unknowns can refer to code. So what do I mean by that? When you call define attribute in that class method that I showed you earlier, you pass a name for the attribute. That name ends up defining a method. So that name is referring to a method. Okay, and it's hard to see that in this case because this is a really trivial example, but in general, this makes library code much more difficult to reason about and understand. In the case of the knockout, we don't have metaprogramming, so we don't have that. Unknowns cannot refer to code because you can't create methods, you can't create constants, you can't create that stuff dynamically. So we passed the name into getAttribute, and that was just passed on to the hash. It never referred to any code. And this in general makes the knockout case without metaprogramming easier to understand. So if that's the case, then why do we just get rid of metaprogramming? Why would why would gems use metaprogramming if I'm saying it's easier to understand a library without metaprogramming? And this gives you a taste for the reason why, okay? So if we take active record or something and we rip out metaprogramming, you can still implement an ORM without metaprogramming. If anybody has told you you can't, I think that's a lie. You can, but this is what it's going to look like, right? You're going to be, so now we have two concepts. We have attribute and association. You have to call get association, get attribute, set attribute, get association. I mean, it's really a mess, right? Because you can't speak the domain language. So the question is, would you use this, right? You could do this, but I mean, would any of you as an application developer, would you use this? Well, there's a really subtle point here, right? Which is that as the application developer, those things that are unknown that I showed you, those are not unknown to you, right? You know what your column names are. You know what your table names are. So you could go in there without metaprogramming and you could say def title, def abstract. You could define those things. It would be a pain to update and to keep updated, but you could do it. But for the library, it's fundamentally impossible to do that. Those are fundamentally unknown values. And this is what metaprogramming does for gem authors. It allows you to speak the domain language, right? So we can do this. This is what we're used to. So that takes away the advantage of the application custom building these things themselves. So here's the kind of the message. Metaprogramming levels the playing field by enabling libraries to translate unknowns into code. Okay, this is kind of a way of thinking about metaprogramming that is actually meaningful. Like you can actually work with it. So you can actually, this actually reveals things. And as an example of that, like I mentioned, what's unknown at the library level, or the gem level, well, stuff like the column names, the tables, this kind of stuff. What's unknown at the application, for the application? What's unknown for the application? I mean, the classic what I'm thinking about is user data. Like, if you're an application, you don't know what user input is going to come to your application, right? As a library, you don't know what the attribute names are going to be. But for the application, you don't know what your user input is going to be. But do you want to translate your user input into code? And the answer is like not unless you're suicidal, because you're not going to have a very fun time with that. So this kind of explains the divide between applications and libraries. For libraries, metaprogramming is a leveler. For applications, it's like a menace, right? You have to control it, keep it under control. The other thing it does, though, it also kind of pokes some holes in our working definition of metaprogramming. Remember, the working definition was a what definition, where you just say, any of those methods, that's metaprogramming. I want to kind of show you that there are problems with that, and that reveals something too. So let's take some other really, really easy examples. So eval foo. So if we say eval is metaprogramming, this is metaprogramming, right? But this feels kind of wrong, because what does this evaluate to? This evaluates to calling the method foo or the variable foo. Like, this is not translating unknowns into code. Okay, but in our original definition, this would be called metaprogramming. So what about this now? So now we have a string, we append the string to foo, and then we eval that. Well, we still know what it is, it doesn't really change anything. So how do you make something unknown? You wrap it in a method, like this. So now we have a method fooval. It takes a string, it appends it to foo, it evals that. It's a really useless method. But it is now translating unknowns into code. And this lines up with our original definition. It has eval there for its metaprogramming. So this one kind of lines up. Okay, let's take another one. Add a writer with a string foo. So this is like the furthest thing from metaprogramming you can imagine, right? I mean, this is like we use this in plain old Ruby objects, same as add a reader, add a accessor, these kind of things. What does this evaluate to? It evaluates to defining a method foo, and this is definitely not translating unknowns into code. So this one seems okay. Okay. What about this? Can you all read that? So this is define writer. This is similar to the second half of the define attribute method I mentioned earlier, except now we're setting an instance variable, but it's the same idea. So we're taking a name, and then we're creating a method with define method. So in our original working definition, this is metaprogramming, because we're using define methods, so it's metaprogramming. And it is translating unknowns into code, right? It's taking the name, which we don't know, and then it's defining a method from that. Okay, but that's the same as this. So something's wrong, right? At this point, something is wrong. Because we said AutoWriter was not metaprogramming, but this is definitely metaprogramming. It's definitely translating unknowns into code anyway. But we're just basically aliasing AutoWriter. And the problem here is that we're not taking context into account, right? We're just saying that method is metaprogramming, but you have to consider whether things are known or not known. In 99% of cases where we use AutoWriter or AutoReader or AutoAccessor, we pass a string or a symbol to it. So those are known values, so we don't have this. But if you pass something unknown, then actually, in a new definition that I'm trying to show you here, this is metaprogramming actually. Okay, so let's kind of visualize these results. So we have one Venn diagram here. This is our what definition, our original what definition. This is contains metaprogramming methods. So remember, we had the control. The control had a defined method, so it's metaprogramming in that definition. Then there's a knockout. The knockout did not contain any of those methods, so it was not metaprogramming. Those seem fine. Now we add the other data points. Let's see if this works. So, and there were two here that seemed funny, right? The eval foo thing here. That felt like it shouldn't really be in there because it just evaluates to calling the method foo, which is not really metaprogramming like. And then the other one was these two, define writers. Those were like basically the same, right? We just refactored one, but one is in and one is out. The one that's out is out because we changed it to an outer writer. So we want a definition that will actually capture what we care about here. So now we have this is a new definition, right? And the thing about this is going to be like a how definition. We care about what's actually happening, what things are actually doing, right? And now it doesn't contain the eval foo, but it does contain both defined writers. And this is going to be, we're going to define it here based on the idea of normal programming. So instead of thinking about metaprogramming as the kind of oddball out, we're going to think as normal programming as the oddball out. And we're going to say, in this set, these are things that are not reducible to normal programming. Okay? So we're going to kind of invert this whole thing now. So now we have normal programming is code that cannot convert unknowns into code. So this actually will include things like defined method if you're passing it a string and the body is known. It'll not include things like AutoWriter if you don't know what the name of the attribute is. So now we can zoom out. And now we have this, right, which is the inverse of what I showed you just a few seconds back. Normal programming is this smaller set here. Okay, normal programming, another way of thinking about this is, normal programming is code where you cannot have data that refers back to code. You don't, in general, this is the case you have. You don't have data that refers to code. This is kind of easier to, like I said, easier to reason about. It's what we normally want to work with if possible. But the much bigger space of programming and computation in general doesn't follow that rule, right? It does whatever it wants. And so you can have data referring to code and whatever. And what do our libraries do then in this picture? They go out of this safe space that we have. Not always, but in many cases. They go out there and they leverage this ability to have data that refers back to code. They leverage this ability to translate unknowns into code. To do what I'm going to describe next, which is to build software that solves generic problems. And I'm going to refer to that software as generic software. Okay, so what's generic software? This is the second part of the talk. I didn't come up with this term. So this is Jeremy Evans. He's the author of a number of gems. The most well-known one is a gem called SQL, which is an ORM like active record, except better. Sorry, I had to stick that one in there. So this is a quote from a talk in 2012 on the development of SQL. It's buried in the slides if you go looking for it. You really have to dig to find it. He says, one of the best ways to write flexible software is to write generic software. Instead of designing a single API that completely handles a specific case, you write multiple APIs that handle smaller, more generic parts of that use case, and then handling the entire case is just gluing those parts together. So I think this is a great quote. We're going to go ahead and we're going to build an example of this now in the last 5-10 minutes of this talk. The essence I'm going to say, this gluing here, this glue in any case where you need to speak the domain language, this is going to be metaprogramming based, according to the definition that I just gave you now, okay? So we need an example. We need another concept. We already used attribute. So we're going to take another one. This is about as generic as you can get, I think. Equality. We're going to use, in Ruby, there's a number of different types of equality. We're going to use double equals equality. Double equals equality just says if two objects have the same content, more or less, they're equal. So two strings with the characters FOO are double equals equals. I think we probably know this pretty well. Okay, so we need some examples, some concrete cases. So I'm going to go not to SQL. Sorry if Jeremy's watching this. We're going to go to Rails. Where else do we go? And grep, and we get a whole bunch of files back that have this actually. And I'm just going to pick a test file just because the names are a little more intuitive. Customer RB. It has two classes that we're going to look at. The first one is called address. It's got an attr reader with street, city, country. And then it's got an equals method in there. And the equals says, if the other one is also an address, and we have the same street, and the same city, and the same country, then we're equals. There's another class called GPS location, which has methods latitude and longitude. They're defined a bit differently, but that doesn't matter for us. There's a double equals method. The double equals method is defined as if the other one has the same latitude as me and the same longitude as me, we're equal. So this is pretty basic stuff. Let's line these up together. I'm going to drop everything else that's in those classes. Just assume that it's there, just to make it easier to work with. So you notice there's a small difference here. In the first one, there's this other is a self class. That's just checking that the other one's an address. It's not going to change anything, so I'm just going to drop it. You can add it back in at the end if you want to. So this is what we have now. We want to extract what is similar about these two, right? Because we're trying to build this idea of generic software here. So how are we going to do this? I'm going to step through this, okay? I think I have enough time to do this not too quickly. So the first thing we're going to do, in Ruby, I mentioned earlier, I think, calling a method is the same thing as sending a message to the object with that name. So we can do this. This is exactly the same thing, right? So we send, instead of calling street, we say send street. And then we check if it's equal. So that's exactly the same. Okay, now I'm going to drop GPS location because the steps are going to be exactly the same for GPS location. Okay, our next step here, the box in the bottom there is what we had before, so you can see it. Now what we've done is we've extracted the street, city, and country into an array. Okay, and then we're calling the enumerator method all on that array. All takes a block and passes each element of the array to the block, and then it ANDs the result to that. And that's basically exactly what we were doing a second ago. So now we have the array, we call all, we pass the block. I want to point out here, we have this key, right? This key in the block. This is the first sign of our abstraction. Okay, key, what is a key? A key is a street, city, country. In the case of GPS location, that would be latitude, longitude. So keys are the things that define equality on these objects. Okay, so now what are we going to do? We're going to name this thing keys, and then we just call all in keys. So nothing big's changed there. Okay, now what are we going to do? Now we're going to switch the def to a defined method. Now remember, in the working definition that we started from, if you use defined method, okay, that's metaprogramming, right? But nothing's actually changed here, right? If you actually think about this, it's doing exactly the same thing. The only difference is that defined method's a bit slower than def, but otherwise it's exactly the same thing, right? So that definition is not telling you anything really meaningful here. But the new definition says this is not metaprogramming because it's reducible to normal programming. That's what that definition meant, right? So nothing's changed as far as our new definition, but it will soon. Okay, so let's pull the keys, let's hoist them outside of the block here. You can do that because defined method takes a block, and blocks have an open scope, which I mentioned was one of those tricks earlier. So you can do this. Inside the block, you can see those keys. Okay, now we're going to change our perspective. We're going to consider these keys as method arguments, as arguments to a method we're going to create. And notice if I had GPS location down below, those keys would be different. They would be latitude, longitude. So that we've extracted what's different about these two. This is going to be our method body. This is now what's the same about this one and GPS location. Okay, so we create a method now. We call the method equalize. It's a class method on address. It takes a set of keys with a splat there so we can pass them as arguments. Then it defines the method with those keys. And then we call equalize with street, city, and country. Okay, this is the really important step. But it's not yet extracted in something we can share. So we'll extract it into a module. The body is the same as before. It has an equalize method. It takes a set of keys. Remember, this is now the unknown. This is going to be the unknown for the gem that we're building. And then address now just extends equalizer and calls equalize on street, city, and country. So we've extracted that common part into a module, and now we're going to create a gem. What do you do with a gem? You require it. So now this is looking pretty nice and neat, right? Because you look at address, it refactored a couple lines out of address, but also it tells you exactly what's important, right? What's important about this address? It's a street, city, and country, because that's what defines equality. So that's a sign of a good abstraction. And in that diagram that I showed you earlier, what did we do? Well, originally we were in that space of normal programming with address and GPS location. Then we extracted this thing, an equalizer. And equalizer has these keys, and the keys refer, remember, those keys refer to code. They refer to method names that are used in the equalize method. So this equalizer is outside of that safe space. It's in that bigger space of generic software. Okay? And now, because it's in that bigger space, it can solve a whole class of problems. So we can apply it to a lot of other files, a lot of those other files in that list I showed you earlier, and it'll work. Actually, you can do it, and actually it'll show you a lot of interesting things about all these different classes in Rails. So I want to go back quickly to the module again. This is equalizer. It's got a method equalize. I want to point out some interesting things here. This define method here, right? There's define method. You can't replace define method here by anything else. So you can't replace it by def because you need that open scope in order for the keys to be passed through into the block of that method. So define method is actually really essential here. The same goes for send. If you see the send there, you've got keys. Those are names of methods. Without send, you can't call those methods, right? The only other way to do this is with eval. Eval is the universal solvent. It dissolves anything, including your hands. You don't want to use it. So Ruby provides you the other methods. And when you solve a generic problem with metaprogramming, you see why these methods are there because there's no other way to do this. OK, quickly, I don't have much time left. Now we can build on this abstraction, right? So we can create a method, inspect. Inspect, now, because we have these keys which define equality, they also basically define identity of the object. So if we want to get, we have the address and we want to inspect the address, well, we can just call those methods and we can just pop them out. So we can get the address where we are today. We just call send key on each of those things and then put it into our inspect method. What else can we do? We can define a method hash. The hash method in Ruby is used to decide if two keys on a hash are to be treated as the same thing. So if we add that into our equalizer, then, for example, we can create a hash of visits that we've been to, places we've been to, and then we have GPS locations. And if two GPS locations are different objects, but they have the same latitude and longitude, they'll be treated as the same key on that hash. So that's kind of useful. And if this all sounds really kind of useful to you, I have some good news. There's a gem for it. It's called Dry Equalizer. It's one of the Dry RB gems. I'm sure somebody in the audience must have recognized this before I got to this slide. And we've actually basically built most of Dry Equalizer right now. It's done a little bit more elegantly, a little more cleverly, but basically it's the same thing what I just talked about here. So in 5 minutes, we built a generic component. And just as an indication of how important this is a network diagram of all the Dry RB gems, and you can see Dry Equalizer has a really important role there. OK, I'm almost out of time. I want to come back to the title of this talk. The title of this talk was Metaprogramming for Generalists. It was not metaprogramming and generalization or metaprogramming and generic problems. Why did I use the word generalist? So generalist usually means, in sort of casual speak, somebody who can jump from one field to another and has some kind of broad knowledge across all these different fields, right? But the meaning that I intended with this was more something like this, right? Somebody who can dig down, really deep down, to the kind of core concepts that underlie all kinds of different problems. Concepts like attribute inequality. And then wrap those concepts in an abstraction, like the equalizer module we saw, and then share that abstraction as generic software, and then build on the abstraction, like we saw also just a second ago. And this is going to be my kind of appeal at the end of this talk, is that I think we need more of us to be these generalists in our community, right? We really need to build more of this generic software, right? Generic problems, solving generic problems benefits everybody at all levels by making every specific instance of that generic problem easier to solve, right? That's the magic of metaprogramming. That's the metaprogramming magic that makes our ecosystem so powerful. That's what makes Ruby the language that it is. Thank you.